Hello, this video is on identifying excluded values and simplifying rational expressions. An excluded value is something we talked about yesterday. It is any x value that makes y undefined. So I gave you an example function here that says y equals 3 divided by x minus 7. So what we're concerned with for these rational expressions and functions is what's happening in the bottom of our fraction because we can't divide by 0. So to find the excluded value, you need to figure out what makes the denominator equal to 0. So here, our excluded value would be x is equal to 7. If I plug that in, I get 3 over 7 minus 7, which is 3 divided by 0, which does not exist. Hence, in this case, our excluded value is 7. Okay, so a rational expression is an algebraic expression whose numerator and denominator are polynomials. So these can take on a few different forms. When we are working with rational expressions, we want to put them in the simplest form possible. So that means we will cancel things out on the top and bottom of our fraction when possible. In this first example, we have 3t cubed over 12t. So you're going to have to think back to some of our rules with exponents for this first example. So if I have 3t cubed, that's like having t times t plus that 3 up there, and that's all over 12t. I can cancel 1t off the top and bottom. So from there I'm left with 3, and then I have 2 t's here, which is t squared over just 12 now. And now I have to decide if I can simplify the 3 over 12. So I have to think about what's the biggest thing I can divide both of those by. In this case, I can divide both by 3. So then I would have 1, or just t squared, since 3 divided by 3 is 1, over 4. That would be my final answer here. Okay, we're going to move on to some more examples. When we're working with these, we are going to practice doing two things. The first is finding the excluded value for the rational expression, and the second is simplifying it if possible. So in this first example, let's do our excluded value first. In the denominator, we have x minus 3, so our excluded value for this first example would be x is equal to 3. There's just one. Okay, second thing is to simplify if possible. So when we simplify, we have to look for a few things. When we have binomials, like we do here, or in some case we'll have trinomials, we have to look for taking out a greatest common factor, or using diamond and box. Since this is just two terms, 3x squared minus 9x, I'm going to look for a GCF. Biggest thing I can take out would be a 3 and 1x. So I take a 3x, that leaves me with x minus 3 in parentheses, and in the bottom I have the original x minus 3. So now you can see after simplifying the top, I have an x minus 3 up top and an x minus 3 in the bottom. Since I have one on the top and one on the bottom, I can cancel those out. And I am just left with 3x. That would be my simplified polynomial. Okay, our next example is c divided by c plus 5. Let's start with our excluded value again. You always want to do the excluded value before you simplify. So in this case, c would have to be negative 5. And now, well, the top is just c, I can't simplify that. And then even looking at this c plus 5, there's no GCF, there's no other way to simplify. So in this case, I cannot simplify the rational expression any further. So that's my final answer. And I do want to clarify, sometimes in these examples, with a c over c plus 5, kids will think that you can just cancel a c out. So they go like that. But that's not true. They have to be totally the same. So what we have is just a plain c up top and a c plus 5. So I can only either cancel this c with another plain c or this c plus 5 with another c plus 5. Hence why we can't simplify anything here. Okay, on to our next example. We have k plus 1 over k squared minus 4k minus 5. Up top, I'm going to start there, k plus 1. There's no GCF, and that's a binomial, so I can't simplify that any further. So that one's just going to stay k plus 1. I do need to factor the bottom to identify my excluded values and to simplify. It is a trinomial, so I'm going to start looking for a GCF first. No GCF for k squared minus 4k minus 5. So I'm going to go to my diamond and box next. So remember, it's for this trinomial here. So I have negative 5k squared and negative 4k. So something that multiplies to give me negative 5k squared but adds to give me negative 4k. That would be negative 5k and 1k. Set up my box. Here is where the factoring comes in again, like we were talking about in class. So I filled in my box, k squared to be k times k. And then I have to multiply k by negative 5 and k by positive 1. So now what I have is k plus 1 all over k plus 1 and k minus 5. So let's pause here. Let's do our excluded values before we simplify. So k would have to be negative 1 or 5. And then I would go ahead and cancel out anything. So here I can cancel this k plus 1 with this k plus 1. In the bottom I still have k minus 5. And up top I don't have anything left, so we put a 1 there. 1 over k minus 5 is my simplified expression. Okay, on to our next example. I would suggest pausing the video and trying it on your own, and then checking it against my work. So first thing first, let's look for simplifying the top part. So in this case I have r plus 2, no GCF, and I can't diamond and box that, so it'll stay the same. That means I need to move on to my r squared plus 7r plus 10. No GCF, but that is a trinomial, so I do need to use diamond and box. So that'll be 5r and 2r. Set up my box. I have r squared, 10, 5r, and 2r. R squared is r times r, which multiply r by 5 and r by 2. So let's rewrite this. Top part stayed r plus 2. Bottom is now r plus 5 and r plus 2. It's a little sloppy, sorry. Remember to hit pause and identify excluded values next. So that would be r is equal to negative 5 and negative 2. And now I do see I have an r plus 2 up top. That will cancel with an r plus 2 in the bottom. I am left with 1 up top and an r plus 5 in the bottom. Okay, we have 2 examples to go, so keep chugging along with me. Alright, so in the top part I have b squared minus 25. No GCF, but because I have a squared up top, right there, I am going to try to diamond and box this one. It's actually a special case that we talked about a while ago. It's a difference of 2 squares. So if you remember that, go ahead and fill it in if you remember. Also, let's set up our diamond and box. So I'm going to do just this part first. So this is actually my a term, b squared, and my c term is negative 25. So that gives me negative 25 b squared up top. And then I actually have 0b because there's no middle term in the bottom. So it multiplies to give me negative 25b squared, but adds to 0b, negative 5b, and positive 5b. Work my box next. So this part is as usual. B squared minus 25, 5b, negative 5b. So I have to have b times b plus 5 and minus 5. So I've done the top binomial, it's taken care of. And and that's the b minus 5 and b plus 5. I do need to do the bottom now. There's no GCF here, but I need to diamond and box it. So sometimes you have to do this process multiple times. So I have 25b squared. This is actually another special case here, if you remember it, and 10b, so that's going to be 5b and 5b. Set up my box. Sorry, I'm running out of room here. And I have b squared, 25, 5b, and 5b. So then I have b, plus 5, and plus 5. So now I'm going to fill in what I just figured out. So up top in the green here, I have b plus 5 and b minus 5. So I'm subbing that in for the b squared minus 25. And in blue, I had b plus 5 and b plus 5. Okay, so we're going to pause and do our excluded values here. Just one, because there's going to be negative 5 for each parenthesis. And then I'm going to simplify. So I can take away 1 b plus 5 up top and 1 on the bottom. So that'll leave me with, I'm going to write it up here, a b minus 5 divided by b plus 5. Final answer. Okay, this is our last example. Looking up top, I can take a GCF out. I can take 2 out. So that'll leave me with 2 times x minus 5 all over, and I'm actually going to flip these two because I like x squared first, negative x squared plus 25. Now this guy up top doesn't have an x squared, so I'm not worried about doing diamond and box or anything here. The top part right here, 2 times x minus 5, is factored as far as possible, but I do want to take some time to check out my bottom guy because he's got an x squared in there. So there's no GCF, but I want to check my diamond and box. So I get negative 25x squared. Again, no b term, so 0x. Multiplying to negative 25, adding to 0, would be negative 5 and positive 5. Work my box. I'm going to have negative x squared, and then 25, negative 5x, and 5x. I'm going to do positive x, and then I have to multiply by a negative x to get negative x squared. And then this x will multiply by positive 5, and negative x will also multiply by positive 5 to get negative 5x. So now what I have, I'm going to check out where I'm at. Let's erase that. I have 2, for some reason my 2 is not coming out, times x, ooh, hold on guys, times x minus 5 over x plus 5 and negative x plus 5. So something interesting to note here. I have a lot of x's and 5's going on. Sometimes we need to look at the possibility of pulling a negative 1 out of a parenthesis to make something line up. So for example, what I'm looking at right now is this set, x minus 5 and negative x plus 5, because the x's are both opposite signs and so are the 5's. So what I can do is I'm going to take a negative 1 out of this guy. So divide out a negative 1, which will leave me with x minus 5. And let's rewrite this. So up top I still have 2 times x minus 5. Now I have a negative 1 from right here. And I have an x minus 5, and I have an x plus 5. So now you can see we did a little bit of maneuvering there to make them match. So I'm going to pause. My excluded values are x is equal to 5 and negative 5. And now I can cancel an x minus 5 with an x minus 5. So I am left with 2 over negative 1 times x plus 5. Thanks for watching.